Welcome back to another Rhize demo video. In this video, I'm going to show you how you can use Rhize to do data science analysis on your manufacturing data. Specifically, we're going to analyze job performance data from a week of batches. Let me lay out a quick scenario. So the question that I'm investigating is whether performance suffered on Thursday. Thursday felt like an off day at the plant, one of those days where everything felt like it was moving in slow motion. But I'm an engineer, I can't look at my feelings, I must investigate the data to see if there really was a performance difference. And if I discover that there is a performance difference, I have to test that this difference is statistically meaningful, because randomness is always going to happen, especially in complex operations. So I need to test that. So first things first, let's take a look at our query. This is the query to get the data from the day in question. Here is my batch ID. Here is the day I'm looking at. We can see that we got a lot of data. I could even, since this is GraphQL, could be more minimal with what I request, like get only the duration times. These are in seconds. But I'm a human, and what can I do with this big list of data? It doesn't really make any sense to me. I need to be able to visualize this and process in another way. And for that, I'm going to use my Jupyter notebook. If you don't know, Jupyter notebooks are a well-known tool with data scientists and people who work with data. I'm going to integrate my notebook with Rhize so I can query the Rhize API directly from my notebook. To do that, I'm going to import the libraries, then I'm going to get my token. For security, auth is a process that is not running on screen, but the notebook is going to receive a token value that I'll then pass in my GraphQL operation. This is exactly the query that I just ran, only instead of one day, I'm going to run it over a whole series of days. And I'm going to bucket each day of the week into a separate Python list. So Monday jobs get their own list, Wednesday jobs get their own list, and so on. Alright, so I've run it. Now just to check that it works, let's look at a slice of the Thursday jobs. Everything looks normal. So what I'm going to do now is check if the data distributes normally. And to do that, I'm going to plot a histogram. So if the histogram is normal, it should look like our famous bell curve. This does not look exactly correct. It looks like it has a long, right-handed tail. Something is definitely off here with the values. But I don't know where these values are from or what days they are representing. So if I want to compare days, I really need to be able to look at each day side by side. To do that, I'm going to make a box plot. This is going to show me the min-max quartiles and medians of each day. So here we are. As we can see, Monday, Tuesday, Wednesday, and Friday all look quite similar. Thursday is definitely looking different. The data is far more displaced, and it looks like all values just skew higher. So something definitely looks like it's going on here. But I can't rely on looks alone. I also need to test if it's different in a statistically meaningful way. So for that, we're going to run our t-test. A t-test is a famous test in statistics where we can test a sample mean against a population mean. And I happen to know, because this is a long-running operation, that the long-term mean for this job is 945 seconds. So I can compare against the long-term mean. First, the t-test is going to work on a normal distribution. So I'm going to pull up my Thursday data and check and see if it looks normal. It should look like a bell. For a mathematical test, you could run a Shapiro-Wilk test. This is included in the notebook that we'll link. Now I'm going to run a t-test against the population mean. So first, let's check just Friday. That was a more normal day. So if it was normal, our logic is going to tell us that the difference in means is not statistically significant. So here we go. Not statistically significant, failed to reject the null. Alright, so now let's test the date in question, Thursday. Okay, the difference in means is statistically significant, reject the null. So we can say we know that the mean duration for the job response on Thursday is different in a statistically meaningful way than the mean duration of all other runs. So if you wanted to develop on this, we could also run a track and trace query for all of the jobs from that day and then develop a new hypothesis to investigate causes. I could also integrate this with a BPMN workflow. So instead of manually checking if something is off every time I feel like it's off, we could develop alerts that just come automatically when things are skewed. So to wrap up, another fun fact is today I used a t-test. A t-test is a very famous test in statistics, but it actually has its origins in batch manufacturing. It was developed by this guy, who was the head brewer for Guinness. The t-test provided an effective way to do quality tests on small samples of stout. So if you like this video, pour yourself a nice dark beverage, and maybe check out some of the other stuff that we're making. Thanks for watching.